Hi, this is Nathan Tintle. In this Learning Goal video, we're going to talk about how to recognize the relationship between the sample proportion and confidence interval width. We'll use the Affordable Care Act dataset to talk about this learning goal. Now, confidence level, 90%, 95%, and sample size, in this case 1,034, are under the researcher's control. You could increase the sample size or decrease the sample size if you wanted to. One thing that's not under the researcher's control is the sample proportion. In this case, the sample proportion is 69%. 69% of all adults surveyed indicated they had not been affected by the new law. But the value of the sample proportion does have an impact on confidence interval width. We'll take a look at this by recognizing that 19% of the folks surveyed said they had been hurt by the new law. If you compute a confidence interval on this data using the theory-based applet, which is fine here because our validity conditions are met, we see that the confidence interval is 16.61% to 21.39%. If you compare the margin of error between the two confidence intervals, so the first confidence interval has a margin of error of 2.39%. This is a margin of error on the proportion of people who said they had been hurt by the new law. When we contrast this to the margin of error on the proportion of people who say that they have not been impacted by the law, we see that that margin of error is larger, 2.82%. The general rule is this: the margin of error is smaller the farther away you are from 50%. So when your sample proportion is close to 50%, you have a larger margin of error. As you move towards 0 or 1, you get a smaller margin of error. Now, this relationship between sample proportion and margin of error is one of the less important ones, mainly because it's not under the researcher's control. Oftentimes, polls actually only report the maximum margin of error for the whole study. So if you see a Gallup poll or something like that where they ask a whole series of questions where there's all kinds of different sample proportions and thus actually lots of different margins of error, they might just report the maximum margin of error for the entire survey and say something like, well, the margin of error was 3%, which really means that the maximum margin of error you're going to see here is 3%, and for some sample proportions it may be smaller than that. Couple little comments on intuition. How do you really understand this relationship or remember it? Well, graphically, if you think about the distribution of sample statistics and realize that that distribution, think of a null distribution, must be between 0 and 1. Well, if you kind of slide that null distribution back and forth along the x-axis, as you get close to 0 and 1, that null distribution kind of has to shrink down because it can't cross 0 and it can't cross 1, so it can't spread out as much. There's not as much variability. That leads to smaller margins of error because the variability of that distribution is in fact the standard error. It's clearer in the formula if you just look at the numerator of this formula, p hat times 1 minus p hat. That value, the numerator of the standard error, is as big as it can be at 0.5 and gets smaller as you move farther away from 0.5.